My name is Abhinav. I am a CS undergrad at BIT Vellore. I do web development, UI, UX, and stuff like that. Um, it's okay. Yeah, I do web development and stuff like that. In this stream, I'm going to be talking about blockchain and should we be using blockchain to develop web apps using blockchain. First of all, I think a little introduction on blockchain is required. Uh, yeah, I'll be using this board to demonstrate what a basic blockchain looks like. If just ensuring one last time if I'm audible, and then I'm moving. Just send a text that I'm audible.
Yeah, your voice is audible.
Okay. So, blockchain is, you might have heard of the term distributed ledger. So I'll get to that in a while, but first I think it's important to explain what a centralized system would look like, and I'll be using the example of Bitcoin for this. So let's assume there are two parties, Alice and Bob, and now let's assume that Alice has to give Bob 10 rupees, and both of them have 100 in their account right now. I'm assuming everyone is from India. So yeah, I'm using rupees as term, but you can use dollars or whatever. In a centralized system, Alice would pay Bob, and this is what would look like on the surface. 110 rupees is deducted from Alice's account, and 10 is added to Bob's account. But under the hood, a lot of things are happening. So there's multiple ledgers that take place, and by ledgers I mean in the classical term, a ledger is just a notebook that looks, or an accounting ledger is just a place where you store data. But here I mean ledger in the sense of in the by ledger I mean a digital ledger. Uh, a database, if you want to call it. First it'll contact the bank server, then bank will have its own authorization processes, and it'll transfer the amount, 10 rupees, and then it'll contact Bob's account and then pay Bob 10 rupees just by adding 10 rupees to the account. So in this process, sure, 10 rupees is a very small amount, so it might happen very fast. But if you are trying to transfer, say, $1 billion, uh, that would take you about a good 15 days. And by 15 days, I mean 3 days of actual transferring and 12 days of answering to whatever RBI is contacting you with. So, recently in the Bitcoin industry, about 1 billion was transferred for the fees of, I guess, $80. Uh, that fees was not a taxation to Bitcoin. Just for the record, Bitcoin is a cryptocurrency, which is a currency based on blockchain. So this $80 was not a fees to the to any central authority. It was to maintain the system. So in a classical system, if you pay someone $1 billion, you'll have to probably pay a tax of I don't know, $100,000. But in Bitcoin, it was done only for $80. So how does that happen? Now let's go back to the original system of Alice and it's not Alice, it's Alice and say Bob. Now in Alice and Bob, let's go back to the idea that both of them have 100 rupees, and Alice wants to transfer 10 rupees to Bob. The same thing would happen. 10 rupees is deducted from Alice's account, and 10 rupees is added to Bob's account. But instead of it having to go to any central authority like this, say SBI, and then SBI transfers it to whatever Andhra Bank or something that Bob has. Instead of that, all that happens is Alice transfers to Bob's account, and Bob transfers to Alice's account. Or more like, these transactions are just added as is in something called as blocks instead of actual transfers happening. And this transaction 100 minus 10 and 100 plus 10 is just added to a block. And that ladies and gentlemen, is what is called an block, right? That's it. So a chain of these blocks would be a blockchain. So now I'll go a little bit more into what a blockchain would be. If you have any doubts till now, you can shoot me a text. Uh, okay, I'll be answering them anyway. So in terms of uh, uh, since we as web developers are mostly used to centralized systems, it is a little harder to imagine what a non-decentralized system would look like, because in a centralized system you have a server, you have a database, you have a client. I'm just excluding all the load balancers and things. Now an HTTP request is sent. The server queries the database, sends back a response, and that is displayed. So in this, you have a central authority in the form of a server. But as far as decentralized systems go, there are certain blocks or participating members. Yeah, give me a second, just a second. There are certain blocks, and these blocks are what do you what form the chain that makes the blockchain. So suppose it looks a little bit like this. All of these are connected to each other. Blah 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 blah. I can't. I'm not going to draw all the lines. All of these are connected to each other, and these blocks are nothing but a ledger. And by ledger, I mean that these transactions, these beautiful 100 minus 10 that we added over here, would be the transactions that are stored in all of these nodes. Now, there are a lot of concepts behind how consensus is done and all of that, but I'll kind of skip over that. And I'll just get to one more concept before we move into actually developing a React-based blockchain app. Now, I'll not be developing a full-on React-based app. I'll just be, there are some issues with this uh, uh, box. I'll explain what a box is. There's a lot to unfold, but there's some issues with it. So I'll just go over my own app that I developed last week, and probably that should help you out a little bit. Now, this is a blockchain, and this is how a blockchain looks like when you take apart all these other nodes. So let's just consider these three nodes for now. So if you consider these three nodes, this is how they would be connected. Uh, the first block would be something called a genesis block. So a genesis block is something that is the first block in the blockchain. Now, the other two blocks kind of use this block to cryptographically link to it. And what do I mean by cryptographic link is, now I'm going to break down what a block looks like, so that when we are developing something called as a smart contract, we have an idea of what we are exactly developing. Now, where's the line? Just a second. Yeah. Now, this is what a block would look like. So, this would be a hash of the previous block. This would be ledgers or history of transactions, and I don't know, I couldn't shut me. And this would be what would this be? Yeah, this would be a timestamp. I'm not sure. Like it depends from. There's no real centralized protocol for a blockchain. So for Wi-Fi, you have 802.11a, b, and these protocols kind of standardize what a Wi-Fi should look like and how should Wi-Fi serve data. But in blockchain, we use something called as interplanetary file transfer system, and there's no real standardization of it yet, although a lot of companies have tried to do that. So there's no real, like, sure, if you study Bitcoin, this is how it'll look, but if you go over to Ethereum, the story is not very different, but it's kind of different at the same time. Now, so this is the previous hash, this is ledger or history of transactions, this is a timestamp. And this would kind of, since this is a genesis block, so the hash would be 0000. That's just ignore that one. But when it comes to this one, there'd be a ledger of transactions. So say Alice paid 100, Bob paid 10. Chad paid 20, Harish paid 30 rupees, and to whom or whatever those history is stored over here, that history is stored over here. Now a certain timestamp is at the edge of this, and a hash, and this would be hashed, and this would kind of check that hash and cryptographically link it. So now you might have heard of the term tamper-proof when it comes to blockchain. So uh, in a blockchain, if I try to tamper with this data, I would also change the timestamp, which means that uh, I would just change the blockchain. So if I try to tamper with this data, this is not cryptographically linked to this data anymore. This is cryptographically linked to this data, because there is something called as hashing, which I already talked about. So it's hashed by anything. SHA-256 is what I used when I was making my own blockchain in Java. But you can use anything. Usually SHA-2 is used because it is quantum safe, and by that I mean that Grover's algorithm or Shor's algorithm cannot really invert the hash as easily, break the hash as easily. So that's about all the theory you need to know for this. Is for a general blockchain overview. Now there's something called as proof of work and proof of stake in Bitcoin and Ethereum. I'll not really be getting into it right now. It's just a spam mitigation technique. So oh yeah, one more thing. Suppose uh, suppose these two parties have to pay each other. In a blockchain, when you make a payment, all you do is add to the blockchain, and everyone on the node, I'm sorry, yeah, everyone on the node gets a history of that transaction, and that includes this person. So to this person, it would be stored on something called as the wallet. So this is what a wallet looks like. I have a wallet right here with 0 Ethereums right now because I'm not going to buy it because I'm not a crypto trader. So in a real world, if I need to pay someone, all I have to say is, okay, address.txt. So if I have to pay someone in real life, all I would say is, you know what, here's my, just like how you do with Google Pay, instead of giving a number, you give your uh, public address. Now this is elliptically, there's something called as elliptic cryptography, so this is hashed using that. Elliptic cryptography has a lot of problems in the terms that it is not quantum safe. So if I use this, I can actually invert it back to the original hash, which is something called as my public key, my private key. Now I'm not going to show you my private key, but it's possible to do that using. There's a paper on this, and I've not really read through it, but all I know is that it's possible. And, yeah. So this is a public key. Now if I give it to, suppose if I post it on the group, you can use this to transfer me money using send. So you can just look up my public key. This is my public key, so I can't actually do that. And there'd be something called as transaction fee. Now this transaction fee is not a tax, it's an infrastructure tax, so to say, because all these nodes require some money, some incentive to be on the node. And this transaction fee is the node. Now I can make sure that this block is added really, really fast, or it can be added really, really slow, depending on how much money or how much infrastructure tax, so to say, am I ready to pay. Right. Now I'll move on to developing the apps. I'm open to any questions if anyone has any. Okay, just making sure I'm audible so that I move on to the next section. I'm audible, right?
So here we are speaking about a
Yes.
distributed kind of database, right? So there is always a
Yes,
concept
sir.
of I sent you, but you have not received. How is it
E-
taken care in a distributed system?
So one of the things about blockchain is that there's no real concept of you having an account or me having an account. A transaction in a blockchain would look something like this. This public key that is this public key visible right here? This public key that I've added sent uh, some amount of. I have another account. Let me just log into that. Sent a certain amount to. Okay, it's not pasted. Just one second. This is how a transaction ledger would look like. So which is open notepad. Sometimes I hate them. Uh, Now this public key sent 10 rupees to uh, this public key. Now, what you're talking about is called as double spending, and this was a problem till Ethereum and even the newer versions of Bitcoin came into existence. Uh, Double spending is what was one of the biggest scandals in 2014, I guess, with a company called as DAO. But that is now looked after in this using something called a crypto wallet. So when this public key sends 10 rupees to this public key, I don't even need to be logged in to actually check my account. This will already be transferred. This will be validated by everyone on the node. So once you transfer it, it is stored into something called as the public ledger. So once it's stored on your system that you sent me 10 rupees, everyone gets a copy of the fact that, okay, you sent me 10 rupees. And while that may trigger some people and be like, that is not safe or something, this is usually, no one really accesses the history. And these everyone has a history of, okay, Alice paid Bob rupees, and that cannot be questioned later on by Bob, because technically Bob is paid 10 rupees, and it is added to his crypto wallet. So now all he has to do is just log into that specific crypto wallet to get that money. Now this crypto wallet that I have here, which is Abhinav, is not my bank account, so to say. It is just a wallet which allows me to access this ledger and check if this transaction is paid some money. Now, I'll go into the coding details of this thing right now. So, yeah, did I answer your question?
Yes. So how is the problem? So there will be always a problem of offline, right? So a node may be offline among a mesh of nodes.
Yes.
So yeah. So
Uh,
is there any? Yeah.
Yeah, so as far as nodes being offline is concerned, as I said, blockchain is just a chain of usually JSON or text data. So this text data is usually just uh, distributed on the system. Now, these things can go over 80 GB, so not everyone needs to be involved in this actual blockchain data. You can actually just make an HTTP request to it, and you can make your blockchain app right here, which I'll show how to do, using something called a Web3. Now, not everyone needs to be on the system, but people who are on the system usually, even if they do go offline, the moment they come online, they are they can download the data as soon as they come on. And usually that is not the case, because these people are usually being paid bitcoins, which is the transaction fee that I talked about, to stay online in a sense and to verify that all these transactions are happening. And just to be clear, the verification process is automated. It is not every person has to sit down and verify the process. Uh, I think it can get a little complicated. So I think if I move into development, a few things will become clear.
Sure.
And
Thanks.
yeah, one more thing. I have created a short ebook of sorts on blockchain, which I'll share the link to at the end of this session. It's at abhinavmeer.tech/notes.html. I don't know if it's live right now. My yeah, yeah, I've sent the link in the group, but I'm not sure if it's live right now. I'll have to check. So I'll move a little bit into the development area of it, and I'll show what it should look like. Just give me a second. I forgot, where did I save it? Yeah, in fact, I'll do it from scratch. Yes. So there's something called as boxes. So these are the equivalent of how do I put it? These are like templates that you can use to develop your blockchain apps. Now, a blockchain app looks something like, so to access a blockchain app, the first thing that you need is a crypto wallet. Now, this crypto wallet allows you to access main Ethereum network or the multiple networks. Now, these networks are just the chain of blocks. Sorry. And you can also access your local blockchains, which I'll do right now. One problem I face whenever I'm doing a session on blockchain is that there's so much to unpack and so less time. So I'll just use some. Okay, wait a second. Yeah, so this person, Gregory, is one of the best people you can find on blockchains. And he goes into why do you even need blockchain, and like if you do need blockchain, when do you need blockchain. So I'm gonna make a directory for this webinar, and let me just open that one. Yeah, so all I'll do right now is just clone this repository and go over how did this person develop this repository, and how do you actually put your interact with the blockchain. So the first thing I'm going to do is I'll just let's make it larger. I don't know how to make uh, this larger. I guess this is all visible. All I'm doing is a git clone. Visible, right? So yeah. So I'll just save this into a file called social network, and it's going to take a second. Should be done now. Just going to go into it. See what else is visible. Just run a small npm install. If it's going to take a lot of time, I'm going to use something that I've already done before. Till I'm doing that, I'll talk about what a local blockchain is and how do you use it. So there is a suite of tools called Ganache, Truffle. It's actually called Ganache, Truffle. Sorry, I always confused between the two. Sorry about that. So it's called the Truffle suite, and on there's something called as Ganache. So Ganache is a simple one-click blockchain, and what I mean by that is that once you click this, I'll just close this one right now, and I'll open my local Ganache again. So what it does is that fires up a personal Ethereum blockchain for you, really quick. Now it's not. Sometimes my computer becomes really slow. I have no idea why. Not. I have to shift from Windows. Anyway, so I'll start a new workspace here, and as you can see, I just literally did one click. Actually, I have to do 2 more clicks, so that's kind of unfair to call it a one-click blockchain. Yeah. So about Ganache, it's once you fire up Ganache, you'll have a local blockchain running in your local host. It's not an actual blockchain, but it's a very similar representation, simulation of what an actual blockchain looks like. Now, why are we using a local blockchain? Is because unlike web development, we do not have Heroku or AWS where I can get a free account to actually do it, because as I said, infrastructure fees. There is something called as Robston, but it's very complicated too. Like I personally am not a fan of this. So I am going to be using Ganache, and I'm going to be shifting to my localhost 7545. Now, in my notes on blockchain, all of this is there. So in case you miss anything, I'll also add a full tutorial on how to set your system for a blockchain. For blockchain development. Now, I'm going to be naming this Chennai webinar. I already have a Chennai webinar system set up. Sharing this Chennai webinar 2, and on it's 7545. I can change the server whenever I want. So once I've started it, I'm going to copy the private key. Now, as I said, a public key is what you give to other people, and a private key is what you use to log in. Think of it as username, password. So I'm going to be using my private key to log into the system, so to say. And to do that, I go to my MetaMask. I do an import account. I paste my private key, and it's imported with 100 ethers. Now these are not actual ethers; these are just from my local system. And this balance that you see will be affected very soon. But I'll also import one more so that I have a sender account and a receiver account. I'll just rename this to be shit. This is my. I can change. I'll get to that. I have that part here. uh, till this happens. If there's any questions, again, I think better place to answer it would be now because I can actually access this. So it's taking a lot of time. I didn't expect that. Anyway, I'll go into how to actually write these blockchain apps, how to write the backend for them. So just like you use Node or Rails for your backend on a centralized system, in a decentralized system you use something called as smart contracts. It's not a framework, it's not a language, it's a concept given by Nick Szabo in '99, I guess. And he was a lawyer, so all he came up with the idea was using notary contracts and putting them online. And not he, over the time people came up with the idea of using Merkle tree, which is a data structure. This data structure it's basically a tree in which everything is cryptographically linked. If you use GitHub before, GitHub uses a similar kind of tree structure. In fact, it's Merkle tree, and it's an enhanced Merkle tree. So it uses a Merkle tree to, yeah, it's all done. No, it's not done. Yeah, so it uses a Merkle tree. It used to use a Merkle tree to kind of make sure that nothing goes once you put something on the blockchain, nothing goes missing after that. So you can't really delete anything from the chain. Sure, you can fork the blockchain in a different direction, but you can't actually change anything on the blockchain. So yeah, my npm install is done. Now I'll go over to something called as contracts. Oh, where is my contract? Yeah. Now, this person, Gregory, has a very different way of organizing your contracts. But the point is, these contracts build into something called as ABIs, which is application blockchain interface. I'm not sure. It's not that, but it's something like that. I keep forgetting short terms all the time. I'm sorry about that. You have social networks.sol. So .sol is something called is a format for Solidity. Solidity is a language which is previous Turing complete, but Bitcoin was not Turing complete, and a lot of people are like that is a disadvantage, but it's actually an advantage because Turing completeness allows you to write anything and everything, which was one of the reasons why the DAO attack that I talked about on the double spending was such a problem in Ethereum as well in the earlier stages. Now they have kind of gone ahead, like made that better by creating guidelines on how to write Solidity code and and they have also released a new language called Viper, which is Pythonic language, which is not really complete by design. Now, it is C++, JavaScript, and Python mix, but it mostly looks like C and Java to me. I'll just show you how a Solidity program looks like. Now, if you remember in C, there is a hashtag pragma, which is, I think, I don't know what it's called, but it's mostly for, you can suppress warnings with it. You can use hashtags to basically include stuff. Now, just like that, Solidity has something called as pragma, which is used to declare the version type. Now, this is a very important step, and usually when you're coding this, I would suggest that you just copy this and paste this everywhere. So make sure that it is consistent. It's uh, I'll go into I'll sort that out later. But now Solidity has a lot of weird errors, which is mostly versioning errors. Yeah. So now what this app does is make a social network, and this social network allows you to. It's just like Twitter but on a blockchain. Uh, this has not been done before because of the transactional cost is can sometimes be expensive and users don't really want to use that. There's a lot of reasons for why that happens. But for now, a social contract is basically just a class that he has declared, some member functions right here, and then he has declared some methods over here. So I'll ignore these functions for now. because if I get into the depth of the code, it took me some while to understand it. It's not very hard, but then I mean, we're just starting with blockchain. Why do we want to know everything right now anyway? Right? So inside of your social contract class, you have to declare something. You have to declare your first variables, and then you have to declare what a post would look like. So you have to map you into a post, all of these things. So I'll post all of these to the group, and then you can just go through whether it's needed. Right. I posted the GitHub link to the group. You can go through the codes, but right now I'm just going to be explaining on how to actually make these things. So I'm going to be doing something called truffle. Now, when you're making a new blockchain app, to make a new blockchain app, you have to use truffle in it. But since I've already git cloned a completed blockchain app, all I'm going to be doing is do truffle migrate. Now, I also have to make sure that my truffle config is 7545, same port as the port that I'm using, which is 7545. Now I do a truffle migrate, and it'll migrate in a second. You'll see exactly what I meant by transactional process. Could not find suitable what. Okay, sometimes things happen. Oh, it has. Okay, I have no truffle in it. Do I have? Ah, shit. There's a problem. Never mind. I ignore the truffle in it part that I did, and let's just move to CD social network. I'm sorry for this. I didn't change directories, and then I'm expecting it to actually work. Yeah, I'll just do a truffle migrate. Truffle compile is not really that important because truffle migrate does that for you. Let's talk about, as you saw, this, as soon as this happened, a balance was reduced because this block of this smart contract, which was this, was added to my local network, which is blockchain, which is Chennai webinar 2. Let's go to my central account. You already see it reduced. Sometimes it just stops working. Right, now it doesn't really matter. I'll just do a npm start here. So that I'll go into the app.js right now. First I'll delete all this. Yeah, it's now React takes a lot of time on my computer, and basically all my fans start working on the maximum. Doesn't even know a solution to this. Um, okay. There's no real error. It's just my VS Code has a deprecated solidity formatter. Yeah, so here's app.js, and I'll close everything else so that we can focus purely on this. Uh, Now app.js will just fetch my blockchain data using something called as Web3. Now you'll have to install Web3, and then it will use it as a JSON object. It's actually turned into a promise, so you'll have to use await and async a lot. And then it saves it to a state, and then it serves it like how you would serve it using normal React. I'm assuming everyone has some experience with React since we already had high stuff about PWAs. So, which you don't really need React for, but a lot of times PWAs do use React. So, yeah. Um, Yes, sir. So right here I have if net. I'll not go into the code again. This specific person has a very weird way of writing some certain codes. 90% of the times all you have to do is copy paste these things, and these things. These codes are a lot longer, like this much longer. But this person has just shut them down, which is great. So I am calling an asynchronous function load web3. So what this does is that it loads your web3 and it checks that your browser has MetaMask. So this is already launched. I'll go into that in a second. If this person already has MetaMask, if not, then Windows.alert, you should probably have MetaMask. Now I'm going to be calling this over here, but so first this should happen, then anything else should happen. So component will mount is basically something that is used to deal with asynchronous functions. Now, tell me if I'm going too fast or too slow, or if I'm being too boring. It's a new topic, so yeah. Asynchronously, we have declared a function async load blockchain data, and over here we have declared a constant web3. I'll not explain all the code. Don't worry, I'm just uh, one sec. Is my voice lagging? Okay. If my
No,
voice is lagging, let me know. Okay. Uh, we load a Web3, we declare Web3, we instantiate Web3 over here. Sorry, I'm just losing track of what I was doing. Then we do a get accounts, and what this returns is, I'll just do a console.log so that, accounts. So this will basically just give me a list of all the accounts that I have. So what? Okay, sometimes things don't work in my favor. That's fine. Yeah. Okay, it's still showing me one. Okay, for some reason it's just showing me one of these, but what this does is it gets all the accounts that are there in the blockchain, which are these 10 accounts, and then we call the first account. So this will be a sender account. So as you can see right over here, this sender account is added over here. So this sender account also has something called identicon, which is not blockchain feature or anything. It's just something that Gregory has done. Now this sender account is what is this one. The ninth account that I have is, which is the first account over here, is this sender account. So whenever I do a hi how's everyone, which won't work right now, there's some errors in this code. So this will go to my MetaMask, allow confirm, will not do this. So there's some issue with it that doesn't really let me. Yeah, so how's everyone? Yeah, here it's added. So this is how it's added. You do a small transaction, which is of a certain very small amount of ethers to the point that it's not even visible here, and then it's added over here. Now I can tip a 0.1 ether, but the problem is that it's not even. Yeah, so I tipped it 0.01 ether, but the problem is I tipped it with my own account, so that doesn't really make a difference. Now, tipping is what is the equivalent of a like on a decentralized social network, but you can choose to just have a like. I just choose, like, I was working on a paper that was that needed to have tipping in it, so which is why I used this template, but there's templates that use just like. So if I'm clear at this point with everything, which is a lot of things, again, I'll post a tutorial on my website, small written introduction on my website, and the ebooks always there. But if you have any other questions, I'm open to answering them.
So is there any way the username, like the hash content, right, that can be mapped to a person? Like,
Yes. Yes, there is. It's something.
So,
yeah.
Yeah. So it's like then the privacy would be lost, right? So it will be like everyone will know that the X has sent X amount of dollars to Y.
Oh, okay, like that. That is not possible. It's this hash is if suppose Satoshi Nakamoto is a person who transferred a certain amount of money, only then if publicly people know, which is very hard to decipher who owns which account, then they usually can figure it out. It has happened once or twice. But if you're asking, is it possible to have a username instead of this login, which is instead of this complicated version of logging in, then there is something called as Taurus. So Taurus allows one-click login for Web 3.0.
Okay.
This is a very simple. This I'll probably in a future webinar. Hopefully, I'll get to talk about this. Uh, yeah. Anything else?
So, what kind of network it's actually
Yeah.
using blockchain? It's kind of a TCP/IP or a broadcast message. What kind of it's actually using?
I'm sorry, I couldn't hear you.
What kind of protocol does the blockchain actually use?
It uses something called as IPFS. I don't remember the full form. As I said, I'm bad with full form. IPFS.io is what it's the website for IPFS, but it's the protocol that is being presently used. Not all blockchains use IPFS. They mostly use something that is built on top of IPFS. So Tendermint is a blockchain 3.0 system, which if you're in Bangalore right now, or there's a startup called as Cosmos or Persistence One, they are the ones who are kind of working on this. So this uses a completely different, what do you call it, protocol, but that protocol is built on top of IPFS. But most of the Ethereum and all of these things use IPFS, which is very similar to BitTorrent if you've used torrent before. So it does.
So, as you told, it's a BitTorrent, so it doesn't use any traditional like a TCP/IP handshake, is that right? Something.
It does not, but in this scenario, when I'm using Web3 kind of allows you to interact with the blockchain using HTTP request. So that's Web3 is kind of just an API for that. And there's Web3.js, there's Web3 Py, there's Web3 for Java, Go, everything. So Web3 is one of the, it allows you to connect to a Ethereum node using HTTP or IPC connections. It's not inside of the blockchain. Usually interplanetary file system is used, but outside of it, a lot of apps use Web3.js because you can't download the entire blockchain in your local network. Yeah. Okay. Should I move on? So load blockchain data, as I talked about, Web3.js kind of sends an HTTP request to the blockchain, and now my blockchain is currently in my local system, so it's a lot faster. But on the web, it depends on the network speed. Using you at 1 or 2 Mbps, it will be pretty fast. Um, now, now this in this first I get account, then I set my account. This is the sender account. If I change this to say 3, then that'll be like using the third account over here. Now, first I declare a contract using the social network.abi. Now, if I go to social network.abi, I go to the definition. Okay, my VS Code is sometimes just weird. Okay, it doesn't open the obvious things. Now, if I go to my social network.json, this ABI is nothing but a JSON object, which is built when I compile and migrate my contract. If you remember, I did this in the previous step. Over here, when I did that, it actually saves a .json object right over here. Now, I load this JSON object, and I take the key value of ABI, and I access that over here, and I declare that in a function. So when I declare this in a function and I add which network ID is it on, it connects to the blockchain. Now once I'm done with that, I basically just set the state of that blockchain. So if I do a console log, let's hope it prints out this time. So I did a console log, and yes, sir, this object, it's not open. Sometimes I just question my life. Yeah, it's not. So I don't know why this stops working in the last minute. Happens in every webinar. Anyway, so I set a state for the social network, and then I do a post count. Now, in a blockchain, you can't really count your posts because you're on a distributed ledger. To count a post, you'd have to go through the entire ledger history and then pick the certain one. So, as CS 101 would tell us, that the algorithmic complexity would be a lot, I think. I'm not sure how much, because you actually have to do a lot of complicated querying inside of your array as well. Anyway, so we do a simple post count. So whenever I do a create post, if I go back to my contract and go to create post, just 1 second. Uh, yeah, if I go back and look at create post, all it does is it increases the post count by 1. So this helps us kind of keep track of which number of posts, how many posts do we have, so that we don't run a for loop for more than that. If we run a for loop for more than that, it will basically just give us empty values after that, because technically it's just fetching data from a blockchain, and in a distributed system it can just keep going in circles, so to say. Now I set state to my social network, then I set state to a post count, because we'll need to access this later on. Now we run a simple for loop, then we get the posts using methods. So in social network, when I declare this right here, yeah, when I declare this, I basically call the blockchain data, and inside of that there'll be methods, there'll be posts, and there'll be call. So if I don't do call, I actually just call the array, which will have this call function right here. So if I go to my ABI and if I go to my methods, there should be, okay, this, it's not. Anyway, when I'm served the array, the posts is that. So I post exactly the number of posts that are there in the blockchain. Then I call them, set them to a state. Then I sort them by tipping amount, this tipping amount that I was talking about. Then if it's loaded, then I actually post this. Loading would be false, and otherwise social network contract not deployed to detect a network, and I'll just show as loading. So moving on, I do a create post, which is a function which is triggered when I click this share button. Tip post is triggered when I click this, and there's a lot of stuff going on in here. This is kind of complicated to talk about, so I won't just let it pass, because you're doing transferring, money transferring, and there's new methods for transferring money, the new subtlety release. So you can't just be like uh, you can't just create a public function anymore. So there's a payable class to payable, I don't know what do you call it, identifier to it as well. And without this, it won't really work. So yeah, there's that. Now, which is one of the reasons why when I was doing Solidity 5.0, it wasn't detecting it, because I was using sorry, when I was doing Solidity 4.0, it wasn't detecting it because it was using 5.0 stuff. Anyway, moving on, tip post does this. Then there's a constructor. This is basically just for setting the final state for account, social network, post count, posts, and loading. Now this will all change once you're actually in it. Now main will have post, set state, create state, all of these things. Moving on to main.js. Um, I think it should be somewhere here. I've never really worked on this specific. I just know that this exists. Yeah, right here. So what this does is runs maps a key, run as usual, runs a for loop for every creates a component for every post that is actually there, and it'll have post.author. You'll have this small little thing called from way, which is the fundamental unit for a Ethereum. by the way, we're using Ethereum. I think I didn't mention that. Post.content, which is hi, how's everyone? And yeah, that's it. So overall, to summarize, we are using Web3. Yeah, sorry about that. So to summarize, we're using Web3, which is to uh, for I don't know how to for HTTP requests to blockchains, specifically Ethereum, using Ganache, which is used to set up a local blockchain, and we're using React for component-based framework, but that's kind of given. And anything else? I think we're using Truffle to compile and migrate our smart contracts. So that's it from my side for this talk. I know that there was a lot, but you can access this entire talk on. Yeah, everything's there on this. I'll just if I haven't pushed it, I'll just push it by today. So I talk about how to create your own blockchain using JavaScript. There's no Merkle tree implementation, but it's pretty much how blockchains work. And there's a little more to add to it. I'll add that. So that's it from my side. Uh, this is what you learn from this ebook. It's completely free. I know why am I talking like I'm advertising it? I'm not. It's completely free. So that's it from my side. Yeah. If you have any questions, I am very glad to answer them. Thanks for listening.